This video goes with Unit 6, Chemical Equations and Reactions. Essential questions is what is a single replacement reaction and how do you know if an element will be replaced? So single replacement is when you just have one element and a compound being combined, and what happens is that the element kicks out one of the other elements and becomes a part of the compound. So the general formula is you have A and B together, so there's your compound, and you have C by itself, so there's your element. And so C kicks one of them out, so it kicked A out, and now it's combined with C and A is by itself. So they're just kind of trading places. Another way to look at this is with dance partners, someone cutting in. Okay, so again, it's kicking one of them out, and they're changing places. So how this works is a metal is always going to replace a metal. So if you have a positive charge, you have to have another positive charge to be able to kick it out. So for example, zinc metal is placed in a solution of silver nitrate to make silver and zinc nitrate. So I have zinc, silver nitrate, okay, my charges have balanced out, and that makes silver. So zinc is kicking silver out and attaching itself to the nitrate. Remember, we have to do the crisscross. So that is what a single replacement is. We want to go ahead and balance. So I have two nitrates on the right, so I need two on the left. And then now I have two silvers on the left, so now I need two on the right, and now I'm set. Okay, but I recognize that because I see one element and a compound together, and then one of them switching places. Let's look at another one. Lead metal reacts with aqueous copper 2 acetate to make solid copper and lead acetate. So I have lead by itself, I have copper acetate, and I've done my crossover. Okay, and that's going to make copper. And look, now copper's by itself, and lead is with the acetate, and again I did the crossover. Okay, so this is actually already balanced, so I don't have to do anything to that, but again I can recognize it because I have lead by itself, and then I have a compound, and then lead got into the compound and took something out, and so that makes it a single replacement. Okay, so the activity series, some metals are more reactive than others, and so this can kind of help you determine if a reaction is even going to happen. Okay, so each metal can replace any metal below it. So potassium is the most reactive thing, so it can replace any of those. But like gold, there at the bottom of the list, could only replace platinum. The rest of them are too reactive, so the reaction just wouldn't go. Okay, so if we look at this, and we look at aluminum and copper, aluminum should take copper's place because they're both metals and they swap out, and I've done my crossover. And aluminum replaces copper. This reaction would happen in real life because copper is lower than aluminum on that chart I just showed you. And there's a picture of that actually happening. The copper is growing on the aluminum foil. Okay, so here again, if I take this equation and put it backwards, copper and aluminum, that's not going to react because copper is below aluminum, so aluminum has more power than it does. Okay, if we look at this reaction, is it going to happen? I have magnesium trying to replace copper. So is magnesium above copper? I look at the list here on the right, and I see that yes, it's actually quite a bit higher on the list, so that reaction is going to happen, and you can see the products of the reaction, there's been a chemical change, so we know that that worked. So yes, it reacts. So Mg plus CuSO4, I'm going to replace the metal because Mg is positive and so is Cu, so I get Cu by itself, and I get MgSO4. Okay, so let's look at see if a chemical reaction is going to occur on these. So I have tin, and it's magnesium is trying to replace it. Yes, it's going to happen because magnesium is higher on the list. I have zinc trying to replace sodium. That is not going to happen because sodium is the higher one on the list, so this reaction is a no. If I look at this, I have silver and iron. Silver is trying to replace iron, and that's not going to work because silver is lower than iron on the list. And finally, I have zinc and lead. So I look if zinc can replace lead, and that can be happening because zinc is higher than lead on the list. Okay. The other thing that can happen in a single replacement is a nonmetal replaces a nonmetal. So like chlorine gas going through a solution of sodium bromide. Chlorine's negative and bromine's negative, so they have to switch places. So I'm going to Br2 because it's part of Hofbrinkel, or Brinkelhoff, however you've learned that. Your teachers talked about that. And then I have Na combining with Cl. Okay, I want to balance that out so that I have the right number. So I have two Nas on each side, two Brs, and two Cls. Okay, so let's look at another one. Fluorine gas reacts with potassium iodide solution. So I take fluorine and potassium iodide. Fluorine likes to be negative, and so does iodine. So they're going to switch places. So I have I2, now it's by itself. Again, it's part of Brinkelhoff. And then KF. I'm going to balance it. And I can see again that this is a single replacement because I have one element. Even though they're combined to themselves, they're still not combined to anything else with F2 or Cl2. I have one and a compound, and then they're switching places.